If you're going to be working at all in an environment where you need to troubleshoot or understand the routes that your IP packets are taking, then you'll need to know exactly how to read these different routing tables that you'll see. The routing table is essentially a list of directions. This is where your packets will be stopping into a router, looking through the routing table and determining where the next hop will be. Where does it need to go to get to its end station? Every time this packet goes through a router, there's going to be a routing table available there that will help give it directions on exactly where it needs to go. But it's more than just routers. You'll find routing tables within your workstations. You'll find routing tables within printers. Any IP device that needs to send packets out on the network needs to know where to send them, and therefore all of these devices will have routing tables inside of them. To help us understand this concept of routing tables, I've built a little network. It has an internet connection. There is a router that's directly connected to the internet. Inside of that router is another network. That network is connected through a router to another network on the inside. So there are different routing tables all the way through this, and each routing table is going to be a little bit different. Let's look at the routing table for this device. This is a workstation that's on the network, and I've printed out the routing table for that particular device. Let's step through what each one of these things means. So the first thing, the first option in our routing table is 0.0.0.0/0. And in the world of IP networking, that is the default route, which means if there's not a route somewhere in this table for traffic to go, use this default route. The default route says that the gateway for anything that's not on this table is going to be 192.168.1.1, which means if we don't know where to send it, just throw it out here to this router. It will take care of it from there. And it's going to send it to that router on an interface on our machine, which is 192.168.1.22. And if we look over here, that is indeed the IP address of this particular device. The metrics are the costs that are associated with this. If there are two routes to the same place, your routing table will always choose the lowest cost to send it out over the network. Now, if you're looking at a workstation, you'll probably also see a 127.0.0.1. And for those of you that remember, that's our loopback address inside of our workstation. And that means that all of the traffic stays right here on that machine. It doesn't go out to that router through that gateway or out to that router through the interface. Now, there are also some other networks on here too. There's a 192.168.1.0/24. So if any traffic needs to go out to that /24 network, the 1.0 network, then we're going to send it out 192.168.1.22. It doesn't have to go to the router because it's not even leaving this subnet. We're just going to send it right out our interface out to this network. If you're going to 192.168.1.22, well, that's obviously us. It doesn't really need to go anywhere. In fact, you can see the subnet mask on here is a /32, which means it's just us. And it's going to go to 127.0.0.1, which is our loopback address, because obviously these packets aren't going anywhere. And lastly, in the routing table is 192.168.1.255. And for those of you that remember your IP subnetting, that is the broadcast address for this subnet. And if we need to send a broadcast, we need to send it out 192.168.1.22, which is the same interface connected to us on this computer. Now let's change our perspective a little bit. Let's look at the routing table that happens to be on this router. It's going to be a little bit different than what we saw on our workstation, because this router is not only connected to the 192.168.1 network, it is also connected to the 10.1.10 network. This is exactly the configuration I have in my office. So I have a single router right now with these routing tables on there. The default route on this router says if I don't have it in the 10. network and it's not the 192.168.1 network, send it out this gateway out here to 10.1.10.1. And we're going to send it out to that network or that router on this address, 10.1.10.14. So anything that I'm sending out to Google, anything that I'm sending out to my Gmail, it all goes out that particular interface when it hits this router. The router doesn't know exactly how to get to Google. It just knows that it needs to get it to the next hop down the line. If we start looking at what's directly connected to this router, obviously the 10. network is 10.1.10.0/24. We're going to send everything out our .14 address if it needs to go to that subnet. But we've got another subnet connected to this router, which is the 192.168.1 network, and it's always going to go out the 192.168.1.1 address. You can see now that each one of these routing tables has its own similarities, but it's a little bit different depending on what device you're looking at. If we look at this third device, this router that I have on my network, on one side I have put in a completely fake internet address here of 74.208.221.234 so that we can use this as our example. The inside address is 10.1.10.1. This one is a little bit different because this router not only needs to know how to send things out to the internet, how to send my mail to Gmail, how to send information out to these web servers, but it also needs to know how to get back to the 192.168.1 network. So my default route is certainly going to go out to the gateway that's out here on the internet side, this absolutely fake IP address that I've created called 74.208.221.1, and it's going to use this interface of 74.208.221.234 to send that traffic. And of course, it's connected directly to the 10. network, so I see a series of routes of how to get traffic to the 10. network. And since I'm also connected to the 74.208.221 network, I see the routes associated with that one. But in this particular situation, I have these extra routes, the 192.168.1.0, that it needs to know how to get there, and it's going to go to a gateway of 10.1.10.14. This router is simply going to send it down to this next router out of the interface of 10.1.10.1. This is exactly what we need to look at if we're troubleshooting, to know every step along the way, is the router sending the information to the right place? And if we have a problem, then our traffic is not going to go the right direction. Let's have a look at what might happen if we've misconfigured something in our routing table. Here's a very common routing problem. You get some information from your internet service provider, you're setting up your internet router for the first time, but you happen to put in the wrong address for your next hop. And this is a good example of this. This is exactly the same routing table we were just looking at, but instead the gateway has been configured as 74.208.221.5 instead of 221.1. And what's going to happen if this device sends information out to Gmail, it's going to get to this router. This router is going to realize, oh, I need to send you out my default route. Let me send those packets out to 74.208.221.5. That device may exist out there or it may not exist, but it's certainly probably not going to be the router that we need our traffic to go to. So we're going to send all this traffic out to that IP address, and then it's not going to go anywhere. And we never get a response back from Gmail. We never get a response back from the web servers, all because we had the wrong address right there. So as you're troubleshooting your IP routes, make sure you check the routing table of every device along the way to figure out, is the traffic going the right direction? Very often you'll find if you're having a routing problem, you've got a wrong address or a wrong next hop that this traffic needs to go to.